Hi, I'm Cal Mitchell. I run datasystemreviews.com. In this video, I'm going to be comparing the performance of Postgres, MySQL, and MariaDB, the most popular open source databases. To perform this comparison, I created a custom benchmarking tool called Reserva that simulates a high volume digital payment system and deployed it on the hardware you can see in front of me. My tests show that Postgres is the fastest, followed closely by MariaDB. They're basically the same speed. However, MySQL was significantly slower than the other two, and so I recommend using Postgres or MariaDB if you can make that choice. Stick around for the testing methodology and the in-depth performance results. First, let's talk about Reserva, the program that I wrote to benchmark these databases. Reserva is an open source central bank digital currency that is not really a production system, it's just designed to benchmark databases. You can see it on my GitHub page, calmitchell617/Reserva. You can look at the code if you want, but probably you'll just want to know what it's doing at a high level, which is outlined in the README. Before any benchmarking is done, we need to set up the databases. This is accomplished using a custom SQL script for each database. On the right, you can see the one that I used to set up Postgres. The ones for MariaDB and MySQL look largely the same, they just have different syntax. You can actually get a pretty good idea for what Reserva is doing under the hood by looking at the schema that I've created and comparing it to the test that is outlined in Reserva's README. Most of the tables and queries are devoted to authentication and authorization concerns. We don't need to talk too much about that, but let's just skip ahead and talk about the two tables that are under the heaviest load during the benchmarking process, which is the accounts and transfers tables. This is because for each transfer, we need to increment the balance of the person accepting payment and decrement the balance of the account that is making payment. And then we also need to log that transfer in the transfers table. All of this is done inside of either a function or stored procedure so that we can roll back the transaction and make sure everything passes or everything doesn't. You might imagine that if an account is decremented, so if we take someone's money away and we don't give it to the other person, that could be not a great situation. So we need everything to succeed or everything to fail. And that is accomplished using this function, transfer funds, which you can check out if you want. Next, let's talk about the hardware that I use to run these tests. I have two 11th gen Intel mini PCs, one of which has an i5 processor and the other of which has an i7. Importantly, I put Reserva, my benchmarking tool, on the i5 and the database server on the i7. This is because Reserva is less CPU intensive than the database server itself, and I didn't want that to be a bottleneck. I outfitted these PCs with really high end storage and memory components so that I could simulate a modern cloud environment. Each mini PC has been given 64 gigabytes of DDR4 3200 megahertz RAM and a 4 terabyte Samsung 990 Pro disk, a very high quality disk. Let's head over to the AWS and Azure pages to see roughly what instance type would be comparable to these. If we go to the AWS RDS instance type pages and scroll down to the memory optimized database types, we can see something that's roughly comparable. These are Intel processors, so we should use an instance type with an I on the end that have 8 CPU threads or 8 vCPUs and 64 gigabytes of memory. If we go to the Azure page and scroll down, we can go to the memory optimized database types and see that the very catchy name E8DS underscore V5 has 8 vCPUs and 64 gigabytes of RAM with blah, 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 this amount of disk IOPS. Our disk is probably faster than theirs, actually. I've been a professional data engineer for about 5 years. I've worked at a couple of companies and done a good amount of independent contracting. A machine with 8 vCPUs and 64 gigabytes of RAM is certainly a production quality machine. You can definitely rent larger, but it would probably cost about $1,000 to rent one of these machines or one with similar resources from a major cloud provider. Next, I'll talk about how these systems were connected. Each mini PC has a 2.5 gigabit Ethernet jack on the back, which was plugged into a Netgear MS305 passive switch via some cables that I definitely overpaid for on Amazon. They were Rhino 6A 2.5 gigabit Ethernet cables. I could have just plugged them all into my home router, but again, I wanted to simulate a modern cloud environment as much as I can, and those systems will definitely be connected via a switch, not, some consumer level router. And I did see a small improvement in latency as measured via ping when communicating between these two systems using a switch over the router. So, yeah, pretty much simulated a modern cloud environment and the low latency that you might expect between instances, especially in the same subnet or availability zone. Now that you've learned about my testing methodology, let's talk about the results. On the left is a spreadsheet showing how many payments Reserva was able to complete when using each database as a backend each minute over the course of an hour-long test. On the right is a visualization of that spreadsheet. One thing that struck me about the test is how consistent Postgres' performance is throughout the course of the hour. Sure, there was a little bit of variability, especially at the beginning. There was a little bit of a peak before it plateaued, but there's almost no visible variability in the line representing its performance. MariaDB and MySQL, meanwhile, had a little bit of variability from minute to minute, kind of more in line with what I was expecting. And MariaDB in particular had its performance degrade a bit over the course of the hour. Another thing I found interesting is that for a while, MariaDB was outperforming Postgres. I noticed this when I kicked off the tests and thought that maybe MariaDB was going to be the winner in this particular test, but no, it didn't end up being the winner. I think it might be because MariaDB has to write transactions twice to avoid a problem known as torn writes. I don't really have anything to back that up, but that's just my hunch. Unfortunately, MySQL is almost entirely uncompetitive with the other two. Here's one more visualization showing the data in a different way. It is simply the transfers made per second, which I got by summing the amount of payments made over the course of the hour and dividing it by the amount of seconds that are in an hour. As you can see, Postgres is the winner slightly over MariaDB, and MySQL is not very competitive in this particular use case. To wrap things up, Postgres and MariaDB far outperformed MySQL, and I recommend using them if you can. In fact, I was surprised by how poorly MySQL showed in these tests, and it made me wonder if there was something wrong with my benchmarking setup. MariaDB and MySQL used essentially the same config files, so I thought that there wasn't going to be much difference between them, especially considering that they both use the InnoDB storage engine. Stay tuned for more database comparisons soon. My name is Cal Mitchell, and I'm with datasystemreviews.com. Take care.